Okay, so here's our project. It is the effect of travel on baseball performance. The coding was all done using a Jupyter notebook. Um, our original data started like this, which is the events data. So it pulls the event of every at bat since 2000. Um, we used an SQL file that turned into a game logs, which is each individual series and the stats that went along with each series, as well as stadium info, which was all found online, which just has the different stadium and the longitude and latitude that is used to calculate distances. So then we used Panda Data Frame, reading all the data, a variety of different helper functions that calculate stuff like distance and keep matrices that calculate the distance so we can categorize them into different stats. Um, distance, it calculates the batting average for every series, the Ks per nine, walks per nine, which is all stuff that we used. If you run it down here, if you rerun it from scratch, it pulls out all the p-values that I will show you here in just a second, as well as the adjusted winning percentages that are down in here. So if you look at this, these are all the p-values, which was kind of how our project started. So this is the MLB averages for each of these individual stats, which is like the runs per 9 innings if the game or the series were adjusted to 9 innings. Hits per 9, walks per 9, Ks per 9, their batting average, their on-base percentage, their slugging, and their isolated slugging, which are all, isolated power, which are all described in more detail in our full project write-up. As well as for pitching, it was less stats because there's less to look at, but it was still like the pitching hits per 9, walks per 9, Ks per 9, their ERA, and the ISO, so the amount of power they give up. So this is categorized by miles. So we split it into different mile segments. So less than 500, 500 to 1,000, 1,000 to 2,000, and greater than 2,000, which is the distance traveled for each game. And this is only look at the away team stats. So if it's red, that means that the p-value was significant using a significance level of 0.05. If it's red, it's less than the MLB average. If it's green, it's higher. And this is also included in our final write-up. So as you can see, 500 1,000 has a number of significant categories, as well as greater than 2,000 miles. This is categorized by time zones, which as you can see, traveling 3 time zones west had a significant performance decreaser on the away team. 1 time zone west and 1 time zone east were also fairly significant, although some of those were greater and some of those were less, which some of that can be explained by there's more hitter ballparks in a certain part of the country, as well as for the 3 time zones west. That means it has to be an East Coast team traveling all the way to the West Coast and playing generally in a night game. So we then decided after that to look at the actual percentage difference. So it's called the Pythagorean winning percentage formula, which takes the runs scored and runs allowed and computes how much they should expect, how many games they should expect to win versus how many they actually do. And so this was the change if you adjust the actual runs scored and allowed for the amount of travel they incurred. So as you can see, Pittsburgh actually saw a 10% increase in winning percentage versus what they should have seen based on their lack of travel, while the Expos and the Marlins both had a decrease in their winning percentage compared to the amount they had to travel compared to other teams. This actually resulted in last season, the Brewers should have made the playoffs over the Twins, considering the Twins had a greater or a more helpful impact from their travel.